Hello. For this example, we are creating a reliability curve, and we have a company that's developing a new computer chip. Each month, a collection of the prototypes is tested, and the percentage P of chips that operate successfully is recorded. And so we have that data here. M is our months, M is actually our X in this scenario. P is our percent of success, that is our Y, so this is saying 22% of those prototypes worked. And by month 7, 71% of those prototypes worked. The first thing that we're asked to do is to find a logistic model for this data. And we do not have a method for finding a logistic model by hand, so we are totally reliant on our calculator to come up with the logistic model. So let me go to my calculator and then we'll continue from there. So here in my calculator, I'm going to go to Stat and I'm going to choose to Edit. And I actually went in ahead of time and typed in these values. So in list 1 we have the months, 1 through 7, and in list 2 we have the percent of those prototypes that worked. So once I have my data, I go back to Stat, I go over to Calculate, and I am looking in this list of regressions that my calculator does for Logistic. And I found it there as option B. So I hit Enter, and then we have the option to store our equation, and so I'm going to do that, and I use the vars button, Y variables, function, and enter again for Y1. So I move down here and I calculate this. Now on my handheld calculator, I definitely have to wait a minute. Even here on the computer, it did not happen instantaneously. So literally, you're going to sit there and wait 30 seconds, 60 seconds, a bit for your calculator to do all this math. And then once your calculator does all the math, you see up here at the top is the logistic formula. C is that limiting value, so that's the 102.55. A in here, which is B in our formula in our book, is this first number, and the B here is where we had R in our formula. And so we have the logistic model. So going back to my PowerPoint slide, I find the logistic model for P, the percent of success. So P equals, and we had 102.55 over 1 plus 5.128 e to the negative 0.349, and then our calculator uses X. In terms of this problem, it is time and it is in months. So next thing that it asks us to do is to create the reliability curve, and that is just a graph of the percentage of successes versus time. And we're to do this for data and model up to 15 months. So I'm going to go back to my calculator. In my calculator, I had stored this equation. So when I go to my Y equals, my calculator typed it there, and you see my calculator even uses the parentheses. I was asked to see my data as well, so I need to turn on my stat plot. So I go up, hit enter, and when I arrow back down, that is dark, so I know that that's on to show me my data. And then I need to make a window. So the problem told me to go up to 15 months, so 0 to 15 in the X direction. And we saw that the limiting value, the K on top of our formula, is equal to 102.55, so I'm going to go just slightly higher than that at 103. So I hit graph, and it did a really nice job. So here's all my data points, and here's my logistic curve coming through those data points, starting out exponential and then leveling off over time. So reliability curve, I'll draw it down here. We had 0 to 15, and that was months. we went up to 103, and this axis is percent, and our curve came up and leveled off, and our data points, which I'm not going to draw perfectly, but they were very close to our curve right in here. All right, so it tells us next the chip is ready for production when reliability reaches 95%. That percent is a Y value. I can tell that from my graph here. And so I'm going to solve this by graphing and putting in 95% as my Y2. It also tells me to round my answer to the nearest month. So back to my graphing calculator. Because I know a Y value, I'm going into Y equals. I want to know when this reaches 95%. And so I add that in my Y equals and I hit graph. I see the point of intersection right here, so I'll find that by using second trace intersect, hitting enter. And I get the intersection is 11.92, and they told me to round to the nearest month, so I'll round that to 12 months. So this is going to happen. It's ready for production at 12 months out. Next question, what is the maximum percentage of success according to your model? Does that make any sense? So according to our model, the maximum, this limiting value, is the K value in our model, which is on top of the fraction. So our maximum is 102.55%. And does that make sense? Not entirely. So we can't have more than 100% success. But it's close. So I feel like it's sort of like a rounding issue. Had this number up top here been like 160%, I would have been like, no, not realistic at all. There's no way you're ever going to reach that. But we would hope that this would get very close to 100% success. I know when I buy a product, I want it to work 100% of the time. And so having this at 102.55 seems somewhat reasonable, even though it will never be exactly that. Final question. During what month did the company have the biggest increase? So this biggest increase in the percentage of successes is that same idea as fastest growth. And fastest growth in a logistic curve happens at the point of inflection. And we know that the point of inflection happens at half of the K value, which in this case, the limiting value was 102.55. And doing the math on that means that we are looking for 51.275%. All right, so I'm going to go back to my calculator. The percent was the Y value, so I'm going to need to put this into my Y equals. So going into Y equals, I no longer need the 95%, but I can replace that with the 51.275. And I graph. And we see that coming through right in the middle of the steep uphill, which is right where we expect the point of inflection, and it's where that change in concavity occurs. And I can find that ordered pair using the intersect command. And I get an answer here of 4.679 months. So during what month? So during the 4th month, because we had this right in here. Oops, right in here, 4.679 9, or 6, 8. If I look in my data, the 4th month to the 5th month, right in here, we had an increase of 9. 5th month to 6 months, we had another increase of 9, and then our increases start to go down, and before that, our increases were a little bit less as well. So right in here, months 4 and 5 is when we were making the fastest progress in the success of this computer chip.